All right, everyone. Like I said, I hope all is well. Hope everybody's doing okay, and hope we're all ready to go ahead and get this weekend started. No, it's Thursday, but I don't know. I'm ready. So we'll go ahead and knock out. We'll talk about 10.1. So when you go into, and I haven't posted it yet. I need to post it. When you go into WebAssign, by the end of the day, we will you will have chapter seven, review and test, that has been posted already, but also chapter nine's test review and test because we've done all of chapter nine. Chapter nine was only three sections, so we did one, two, and three. And if you missed those lectures, of course, just like any other ones, I will create a YouTube link and shoot that to you. Probably do that between today and tomorrow. So, this weekend you can go into the review. All right, cool, cool. This weekend you can go into the review. See if you have any questions. In the next class, I'll open the floor for questions on whatever. So whether it's chapter seven or chapter nine, you can ask whatever questions you like. But if you guys don't have anything, then of course I have to keep rolling. Can't just have just dead space and just um, nothing going on. Good morning, Miss Wilson. Um, So if you have questions, though, the floor will be open for you next class to ask whatever questions you want. Like I said, whether it's on chapter seven or chapter nine, doesn't matter what you have questions on. Feel free to ask them on next class. But if no one has anything, then we'll go ahead and keep moving forward. All right. So let's go ahead and look at 10.1 today, and then we'll close out for the weekend. All right. So 10.1 is the rectangular coordinate system. Uh, this MDE 60 was just a note to myself. I have the notes in another class, so I'm going to flip the page. Just give you an opportunity to copy the title of the section. All right. So once again, this is not for you guys, though, just for me. All right. So the rectangular coordinate system, or Cartesian coordinate plane, is made up of two axes, your horizontal axis and your vertical axis. Where they intersect is your origin. Coordinates of your origin is 0, 0. Everything to the right of your origin is positive. Everything to the left of your origin is negative. Everything above your origin positive. Everything below your origin is negative. They make four quadrants going counterclockwise. Quadrant 1, 2, 3, and 4. In order to get into quadrant 1, you have to make two positive moves. Quadrant 2, negative, then positive. Quadrant 3, two negative moves. And then quadrant 4, positive, and then a negative move. Oh, there was a hand that was raised. I think it was Malik, I think. Yep. Mr. Harris.
I'm on 10.1, right?
Yes, sir.
All right. I was confused because 10.1 and that was at 5.1. I was
Yeah, that was notes. That's what I was saying. Those were notes from another class. So I was just shifting to those notes instead of rewriting the notes. I shifted to another class notes. And then so the notes are the same. Math doesn't change. It's just that it was from another class. So I was just using notes that I had already written up.
like,
Yeah, no problem. No problem. Not a problem at all. And always make sure you guys, ask your questions because, your question could be someone else's question as well. So yeah, there's no problem. Not a problem at all. So we'll be graphing by what we call ordered pairs. And they call ordered pairs because the order matters. And so you will have your X and then your Y. Your X move will always be first, then your Y move. So your horizontal move, then your vertical move. So you can think about X comes before Y in your alphabet, or you walk and then go down in the elevator, or run and then jump. Whichever way helps you to think about which one goes first. Is always your horizontal move, then your vertical move. All right. Any questions? All right, let me erase some of these. All right, so let's just do a few points and talk about where they are located, and I'll make sure we're okay with graphing before we go any further. So if I have the point 2,5, you always start at your origin if you have a point, and you go to the right 2, and then up 5. That'll put us right here in quadrant 1. So 2 positive moves puts us in quadrant 1, as mentioned before. Start at your origin, go to the right 2, up 5, puts us in quadrant 1. Second point, -1, -3. Start at my origin, I go to the left 1, down 3. That puts me in quadrant 2. -4, 2. I go to the left 4, up 2. Oh, hold on. I put quadrant 2. I meant this quadrant 3. Sorry, y'all. This is quadrant 3 here. I made a mistake and wrote quadrant 2. Now, -4, 2 puts me in quadrant 2. So that was my fault. And then 1, -5, go to the right 1, 5. That puts me in quadrant 4. All right, questions on those 4 before we look at the last 2? All right, so 3, 0. Go to the right 3. Nowhere for Y. 0, that puts me right here, which doesn't put me in any quadrant. It puts me on the x-axis. Then for that last one, I don't move to the right or left because x is 0, but I go up 3. And that puts me on the y-axis. Any questions before we go any further? All right. All right, solutions. An ordered pair is a solution of an equation if the equation is true after the ordered pair is plugged in or substituted in. All right. So if I have the equation 4x minus 3y equal to -2, and they want me
What
to
was the
test if,
calculation of that again?
so right there, An order pair is a solution of an equation if an equation is true after the order pair is plugged in. So 4x minus 3y equal to negative 2. Order pair they want us to test is 1 and 2. And don't forget, the first part of your ordered pair, or the first component of your ordered pair, is always x. The second part is y. So you plug those values in accordingly and see if a true statement is created. So it's 4 times 1 minus 3 times 2 equal to negative 2. 4 times 1 is 4. 3 times 2 is 6. So 4 minus 6 is negative 2. Negative 2 is equal to negative 2 is true. So yes, it is a solution. So there are infinitely many solutions to a linear equation. So when you have your graph, and I should have said to an equation period, but when you have a graph, whatever's on this line represent the order pairs that are solutions. And so when we get to graphing our lines, you'll see more so what we mean. But there are infinitely many solutions to your equation. All right, so let's try it again. Just to make sure we're good. This time we have 2 order pairs that we want to try. All right, so our equation is y equal to 3x minus 5. First order pair that we want to try is 2, 3. So once again, don't forget the first part is x, the second part is y. So I'll plug in 3 for y, 2 for x. So that's 3 equal to 6 minus 5. 3 equal to 1. That's not true. So that's not a solution. All right, so doing the next one, we have 3, 4. 3 is x, 4 is y, so that's 4 equal to 3 times 3 minus 5. 4 equal to 9 minus 5. 4 is equal to 4. That's true. And yes, that is a solution. Any questions?
You go back up so I can finish copying one before this.
So that part or
Right there. You can go back there. Right there. Thank you.
Mm-hmm. All right. Anybody else before we go to the next thing? Mm-hmm. All right. So let's look at graphing linear equations. So we're going to have three methods in which we will be able to do so. First one is create an XY chart. And so I saw I scratched out um, chapter 5. That was from the other class. I left it there so I can reference it for later if I need to. But 10.1 is for XY chart intercepts for the intercept method. 10.2 and using your slopes is also in 10.2. So we're going to look at one of those methods today. All right, so we want to create an XY chart. Let's say we have the equation y equal to 2x plus 1. You choose your x values. So I normally choose -1, 0, and 1. But it's up to you what you want to choose. Remember, whatever you choose, you are going to have to graph it. So if you choose 150 and 1 million, that's fine. Just remember you have to calculate with it and you have to graph it. Okay? So, and you'll see why it doesn't matter in a second as to what values you choose as long as you calculate correctly. So you take your x value, plug it into the equation, find the corresponding y value. So if I took -1, plug it into this equation, that would be y equal to 2 times -1 plus 1. So it's -1 plus 1, and that'll be -1. So it just so happens, why am I dragging it like that? Hold on 1 second. I'm trying to figure out what's going on with this marker. Okay. Anyway, I'll figure it out later. So when x is -1, then y is -1. And of course, that's just a coincidence. When you plug in 0, 2 times 0 is 0, plus 1, which is 1. And plug it in. +1, 2 times 1 is 2, plus 1 is 3. So before we look at the graph, questions on how we calculate it. right. So now we can graph those 3 points. We have negative 1, 1, 0, 1, and 3, 1. So go to your origin. Here's one of my lines. Go to the left 1, down 1. Go back to your origin. Nowhere for x but up 1. Then back to your origin. Go to the right 1, up 3. And this is our line. All right. So notice that I put arrows going in each direction of the line. That means it will go on in those directions for infinity. And this is why it doesn't matter what value you choose for x. Because let's say if I chose positive 20, which would be somewhere over here, it will give me a point that's up here somewhere that will still connect with my line. Same thing if it gave me negative 100, it would be way off to the left, but it will give me a value all the way down low that would connect in the direction of the line. So it doesn't matter what points you choose. Just remember that whatever you choose, though, you have to calculate and graph with it. All right, questions before we do another one? All right. So for the next one, we have y equal to negative 3/5 x plus 2. I'm just clearing out the work so I can. All right, so when I look at 3x, negative 3x plus 2, I'm going to choose values that relate to my denominator so that I can cancel out the fact that I have a fraction. So what I'm going to do is choose multiples of my denominator. So notice my x column, I have negative 5, 0, and 5. Remember, before I chose negative 1, 0, and 1. Once again, you have a fraction. So you want to be more strategic. So you want to choose multiples of your denominator. So if that was 3/7, I would be choosing values like 7, 14, 24, 28, excuse me, and so on. Even -7, -14, -28. I want to choose values that the denominator can divide into evenly. If it was 11, I would choose 11, 22, 33, 44, values that 11 can divide into evenly. All right. So whenever you have a fraction in this fashion, you want to choose multiples of the denominator so that they can divide out evenly. All right. So I'm going to plug them in. Negative 3/5 times negative 5. If you're comfortable with canceling first, you can go ahead and do that. If not, just multiply the negative 5 times negative 3. So that's 15/5 plus 2. 15 divided by 5 is 3 plus 2, which is 5. All right. Plug in 0. Negative 3/5 times 0 is 0 plus 2, which is 2. and plugging in positive 5. That'll be a negative 15 divided by 5 plus 2. Negative 3 plus 2 is negative 1. So, time to copy that before we go to the graph. I think there's something wrong with this pen. Making it drag like that. Okay. All right, so this is negative 1. So let's go ahead and graph these points. So we got negative 5, 5. So we go to the left 5, 5. 0, 2. So we go to, do not go to the left or right at all for x, but we go up 2. Then we go back to the origin, go to the right 5. Oh, shoot. I'm sorry. I put that, that should be negative 5, up 5. And then it's right 5, down 1. All right, sorry about that. And that's a line. I missed all my points. Let's try it again. All right. All right. Questions on anything before we talk about one last thing in this section? All right. All right. So then section goes into functions. So before we get to functions, we're going to define what a relation is. Relation is just any set of ordered pairs. So example of that, 1, 2, 3, 4, 5, 6. Your domain is the set of all of your first components of the pairs. So in this case, that would be 1, 3, and 5. And the range is the set of all of your second components. So your ordered pairs, that's 2, 4, and 6. All right, so here is your domain and your range in comparison. Your domain is your first components. Range is your second components, as we already mentioned. So that means your domain will be your x variables, range will be your y variables. Or you can look at it as your input versus your output, independent variable versus your dependent variable, or your horizontal axis versus your vertical axis. All right. So definition of a function. A function is a relation in which the elements from the domain corresponds to exactly one element in the range. All right, so it says determine whether each relation is a function. All right, someone raise their hand. All right, I'll go back here. If I need to go back further, let me know. What's wrong, book? All right, we all right. So we want to determine whether each relation is a function. Is that somebody raising their hand, or was it something else?
Is that your element?
Let me see. Let me see. Um, where are you?
Nah, and I said it says exactly one element.
Yeah. Okay. Yeah. Okay. I wrote that a little sloppy, but yeah, it corresponds to exactly one element in the range. All right. So determine whether each relation is a function. You have 1, 6, 2, 6, 3, 8, 4, 9. So what we're going to do is look at each one individually, and if either one of them, now remember, going back to the definition, a function is a relation in which the elements from the domain corresponds to exactly one element in the range. So we look at each one of them in the domain. If it goes to exactly one element, then it is a function. Even if one or two of them may go to the same element, you have to look at them individually and ask yourself, does this element in your domain go to exactly one element in the range? And like I said, try not to get caught up in looking at the whole set, but just one at a time. So when you look at six, does not six, but look at one, does one go to exactly one element in the range? The answer is yes. Two, does two go to exactly one element in the range? Yes. Even though two goes to the same one that one goes to, we're not looking at them together. We're looking at them individually. Does one go to one element? Yes. Does two go to one element? Yes. Does three go to one element? Yes. Does four go to one element? Yes. So that means yes, it is a function. All right. Questions. So it's okay for different elements to go to the same one in the range, but they can't go to more than one. And you'll see an example of it going to more than one in the next one. All right. That's not right here. So here we have 61628394. And we can do the same mapping that we did in the last one. Your domain is 689. Range is 1, 2, 3, 4. And we look at the first one. 6 goes to 1 and it goes to 2. So that's what we do not need. If there is a element in your domain that goes to more than one element in the range, it is not a function. So we don't have to examine any of the other elements. If we see one that violates the function principle, then it's not a function altogether. All right, questions on that? So just general statements about functions. There can be a repeated value in the range, but no value can repeat in the range. Or no value can repeat in the domain. So if you look at our listing, notice we have 2 6s in a domain that ended up not being a function. But when we go back to our first one, we had our 2 6s in our range, and that was a function. So there can be a repeated value in the range, but no value can repeat in the domain if you want it to be a function. And then the range can go to more than one value, but the domain can only go to one value. All right, questions before we do this last thing. All right. So last thing out of this section is function notation. So y equal to f of x. All it's saying is that wherever you see y, you can put f of x or g of x or h of x. Just depends on what you name your function. So if I have y equal to 2x plus 1, that is the same thing as f of x is equal to 2x plus 1. You can actually literally substitute in f of x for y in your function, and that will be considered function notation. So what that does is that it allows for you to give information or instructions by just writing, in this case, f of negative 5. I mean, f of 5. Even if you didn't write find f of 5, if all you had was f of 5 and you want to know what f of 5 was, then you would have everything you need to know in order to do that. If f of x is already defined, like we have here, f of x is equal to 2x plus 1, and you want to find f of 5, all that means is that you will take 5 and plug it in for x into the equation. So you plug 5 into your equation, that's 2 times 5 plus 1. 2 times 5 is 10. 10 plus 1 is 11. So f of 5 is equal to 11. And so you plug in 5 for x, you got out 11. Remember, your input is your x, your output is your y, input is your domain, output is your range. So I could also rewrite that statement as 5, 11 as my ordered pair. 5 was my x, 11 was my y. All right, so last problem for today, unless you guys need another one, of course, feel free to let me know. It says the surface area of a cube is given by SA of S, so they're calling the function SA, capital S, capital A, equal to 6S squared, where S is the length of one side of the cube. Find the surface area of a cube that has the side of length 10 centimeters. So S is going to be 10 centimeters. So that means as far as the function goes, we're plugging in 10. So that's 6 times 10 squared. Six times 100. And that's 600. Questions, questions, questions. Oh, I just saw one more example. So we'll do that. Then that would be the last one. That'll be the last one. All right, so last one, evaluate g of t equal to 2t squared minus 3t plus 1 when t is equal to negative 2. So all that means is that we will plug in negative 2 into the function and calculate. Negative 2 squared is 4. Negative 3 times negative 2 is a positive 6. Eight plus 6 plus 1. All right, you have a good one as well, Miss Wilson. All right, and then finish it off. 8 plus 6 is 14, plus 1 is 15. And that's it. All right. Questions, concerns, comments? Before we look to close out, make sure we're good, make sure we're straight. That's 10.1. And like I said, next class, it will be open for you guys to ask whatever questions you want to ask, whether it be on chapter 7, chapter 9, or whatever. And all right, see. Oh, back to the session. All right. Okay, okay. Everyone have a good one. Everyone have a great one. So, if you guys are good, I am good. Have a great weekend. Be safe. And I will see you on Tuesday.